Hello, we are here to do question 3 now. Okay, let's start with question 3. This question 3 is a 3 marker. I think it's a simple question. What do you have to do here? You just have to calculate the overall percentage yield. Now this is a two-step process. Step 1, which has got the overall percentage yield of 88%. Then the next one has got 58% percentage yield. As you can see, this is a multi-step process. So in order to find the overall percentage yield of a multi-stage process, what do you need to do? You just need to use a simple formula. What's the formula? Percentage yield, I say py percentage yield is equal to percentage yield of step number 1, which is 88 divided by 100, times the next one is 58 divided by 100, and then you have to times it by 100, which is going to give you 51% overall percentage yield, which is pretty simple. Now the next one is asking you to find the percentage, atom economy. In order to find the atom economy, what is the desired product? Desired product, it has to be this one, right? Because look, I forgot to tell you, this is like a benzene group. Yeah, this is the aldehyde group. This is like a CN part, cyanide part here. And yeah, this has got a carboxyl group here, and then got a hydroxyl group here as well. So but the compound that we are trying to make at the end of the day is mandelic acid, something like that. Anyway, so we need to find the percentage yield of this atom economy of this process. So this is the desired product. So how do you find the percentage atom economy? You can look at the data booklet. Atom economy is equal to molar mass of the desired product. Desired product is C8H8O3 over molar masses of the other things. What are the other reactant? I was meant to say C7H6O plus molar mass of HCN. If you had coefficient, you had to consider the coefficient as well. But in this case, yes, we have to consider the coefficient here because 2 is here. So molar mass, right, of water, which is H2O, times by 2 as well, because the coefficient is 2 is there. So when you sub those values, top number is 152.0. Yeah, and over what? Over 106.0 plus 27.0. HCN is 27, and 2 times 18.0 is 36. When you do this, 152.0 divided by 169.0 times 100, it's going to give you 89.9. This is the answer. We got the answer. All right, simple question, isn't it? Question 3 is simple, man. Okay, all right, question 4. What is wrong with this question? 2 mark. What is wrong with this question? What is wrong? You are just asking me to. What? Propanoic acid with what? Why? 2 marks. 2 marks for what? I don't know, man. Anyway, let's try to do this for a 2 marker. Ionization, any simple question. In this case, which is a what? Propanoic acid, CH3, CH2, COOH. Propanoic acid ionization is an acid-base reaction. It is aqueous. Then you have water. The water has to be a liquid. So acid in acid-base reaction is a weak acid. So it's not the double arrow. Then this hydrogen is going to be given away to water. Water is going to become H3O plus, hydronium, aqueous. Then you get the propanoate ion. When H plus is going to go away, after leaving that electron, it is going to become CH3, C double bond O minus, which is aqueous. Sorry about that. All right. That's simple, isn't it? Why did we have to do a simple question like that? I don't know. Okay. Now, let's try to do question 5 while we are here. Let's try to do question 5. Now, question 5, aspartame question, is a very common question that you will get, right? That you will get. You have to practice that. This is pretty much previous study design, but then again, I mean, talk about aspartame uh, in great detail was part of the last year's, no, previous study design, but we don't tend to talk about this in great detail. But great detail, I was meant to say, but still, you can be given question related to this. All right, now the common questions are asking you to identify certain functional group and asking you to hydrolyze this molecule and determine the determine the name of the molecules that you are going to be forming after hydrolyzing it. Okay, so let's look at this. When aspartame is fully alpha amino acids are produced, draw the structure of one of these alpha amino acid. Now, in order to do this question, or what you need to do is this, right? I mean, they want us to identify the alpha amino acid. In order to identify the alpha amino acid, you need to hydrolyze this molecule. Okay, hydrolysis. Hydrolysis. What are the parts of this? Okay, what are the functional group that are part of this molecule that can be hydrolyzed? In order to understand that, you need to understand what type of functional group are formed during a condensation reaction, because whatever the product or the functional group formed during condensation reactions can be hydrolyzed. So what are the type of functional group that you are going to be forming in a condensation reaction? You know that amide functional group, ester functional group. So those functional group can be hydrolyzed. Okay, where's the ester functional group? Oh, this could be hydrolyzed. You put the water back. Put the water back. Okay. Oh, that's one way of doing that. Oh, that's another way. Oh, that's one way, because this is the amide. Amide functional group can be hydrolyzed pretty similar to H and OH. So what you need to do, identify the ester and the amide functional group and break them apart. In other words, put the water back in. Put the water back in. Okay. Now in this case, what is the okay, let's draw the structure of the molecule that you are going to be formed, even though they are not asking us to do that. You are going to be forming methanol. You see that? But they don't want us to know anything about methanol. Then they are asking us to draw the the alpha amino acid. So this is number 1, this is number 2, and this is number 3. So 1 and 2 should be alpha amino acid. So how do we draw those things? So let's try to draw the number 1. You have H, you have O, then connected to carbon, you have oxygen, then C and H, you see that? Then that connected to the N. Oh, no, simple. That is a C, then you have N. Oh, because they are saying they are amino acid. Then, alrighty, there's a H here. Then you got C, O, OH. Yeah, that's the number 1 molecule. Well, what is this, man? This looks like amino acid. If it is amino acid, you need to have amino functional group, carboxyl functional group. So this is the alpha carbon, alpha C. That's the hydrogen. This is the variable R group. This is the R group. That's the R group. So that's how I identify the alpha amino acid. Yeah. So this seems like, if you look at the data booklet, I know this is alpha amino acid. R group, this R group is CH2COOH, which is what? If you have a look at the data booklet, this is an aspartic acid. This is aspartic acid, right? Aspartic acid. Simple. Okay, what's the other amino acid? Now, okay, they want us to identify the amino acid, so let's try to draw it out, okay? So NH2 group is attached to one of the carbon, so that's what I'm drawing here, this one. And then it is attached to a carbon, you see that? And that carbon is attached to a carbon double bond OH. So I'm drawing so this carbon here has to have a H, and it is attached to CH2. So what I did was I did this carbon, then CH2, then it is attached to what? Be careful drawing these things. I'm not really fan of drawing these things. This is the carbon, and that's the CH2, and that is attached to a benzene ring. Okay, CH2 benzene. Now, if you look at the data booklet, I think this is alpha amino acid as well, but I'm pretty sure this is phenylalanine or something. It's like a phenyl group. Or am I making a mistake somewhere? It is, where's the amino acid? Go and find the amino acid. Wait, which page is that? Silly. Oh, amino acid. Which page is that? Did you find the amino acid, man? No, what are you looking at? You are looking at... Ayo. 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 Okay, oh man, it's too late. That's the problem. Okay, one is the benzene group. This is phenylalanine. Phenylalanine. How did I identify as phenylalanine? This is the R group. That's the R group. Okay. All right. Let me come back and. All right, we are about to do the last question. Let me have a sip of Pepsi and come back. Hang in there. See you soon. Bye bye.